Subscribe now and click on the bell icon to never miss learning from Vedantu.
Is what we learned in the previous class, but through the trigonometric functions. Okay, and we will learn some important aspects of functions like periodicity, even odd functions, right? Through the trigonometric graphs and in general as well. Okay. All right. So hope your students are in. Cool. So just how many of you attended my previous session? Hope all of you attended my previous session as well. Cool. Okay. So let's begin, guys. So I think all of you know the trigonometric functions graph. Okay. This is a very interesting animation which I pretty much I like a lot. What it tells you quickly is, remember when you started learning trigonometry in 11th or maybe in the previous classes or further earlier classes, remember we took a circle whose radius was 1, and if this angle is theta, then this base becomes cos theta, obviously, right? This upon 1 is equal to cos theta, and similarly this perpendicular becomes sine theta. So basically what this animation shows is the way the length of this perpendicular varies is actually the graph of, as I am changing theta, the way the length of the perpendicular is changing, okay, that length of the perpendicular, which is sine theta, is plotted along the axis, which gives you the graph of sine theta, right? So this is the graph of y is equal to sine x or y is equal to sine theta, right? So I think all of you know the sine graph. At 0 it is 0, at pi by 2 it is 1, at pi it is 180, 3 pi by 2 270, and at 2 pi it is 360. Sorry, it is 0 again. And the graph will repeat itself after every 2 pi, right? Got it? One second, guys. So till last time I did the quadratic graph, right? Any doubts about it? You guys are saying yeah. Till last time I just did till the quadratic graph. Okay. Now we are going into the trigonometry graph, right? I hope it's okay with all of you, right? Hai? Okay. So again, cubic and polynomials are the same, Vikram Abhishek. Don't worry. So if you have learned the quadratic graph, then we have actually conceptualized all the polynomial graphs. Okay, Vikram Abhishek. Rest we'll do through the functions now. So nothing I didn't do anything special here. I'm just repeating all that you have already know. You know that this is the graph of y is equal to, the green one is the graph of y is equal to cos x. Alright. And the red one is the graph of y is equal to sin x. I hope all of you know this. Okay? So I'm moving ahead from here. So what I'm going to do now, I'm going to use these sine and cos x graphs, and we'll revise the concepts of graph transformations again, and we'll learn one transformation which we didn't do last time. That was f of ax. Remember, we didn't do f of ax last time. So this is what we will learn today as well, which will lead to the study of periodic functions as well. Okay? So again, a quick revision. Note that the sine graph, the sine or the cosine graphs, right? These graphs repeat themselves after every 2 pi. If you see, whatever that is happening between this 0 to 2 pi, again repeats itself after 2 pi. So this portion of the graph repeats itself after every 2 pi, right? 2 pi, 2 pi, 2 pi, 2 pi. So what we say here is that, before I go ahead, let us make one thing clear that all of you understand this, that 2 pi is the period of, 2 pi is what we call as the period of the sine and the cosine graphs. Alright. And we can also write this as that if the value of sine x is something, say y is equal to sine x, then the value will remain same if we increase the value of x by 2 pi, right? So whatever value that you are getting at any x, if you are getting this value, then you will again get the same value at what? You'll get the same value at x plus 2 pi, alright? So this portion is 2 pi and this is x. So this entire green length is 2 pi plus x. But you can see that whatever was the value of sine at this x is the same value at 2 pi plus x, alright? And same is true for the cos as well, the cosine function as well. Got it? So this tells us that 2 pi is the period of the sine and the cosine function. Alright? Okay, nothing special till here, but again, I will use this notation quite a lot. We typically say that if there is a function fx, if f of x plus t gives you the same value, f of x and f of x plus t, what is t here? 2 pi in this case. Then we say that if there exists such a function, then basically t becomes the period of the function. Very simply speaking, I'll go in further depth about this, but I'm just telling you very superficially the concept of period of the function. Alright? If the function repeats itself after every t. In mathematical terms, f of x will be equal to f of x plus t, as you can see in this graph. Cool? Okay, chalo, let's move ahead from here. Now, another concept that I want to again repeat, which we did very briefly last time, was the concept of even and the odd functions. Okay, so this is even function and this is odd function. Typical example is y equal to x square, y is equal to x cube, or any such function. Okay, so see carefully. In the even function, what will happen? Whatever is the value of function at x, whatever is the value of function at x, okay, exactly same will be the value of the function at minus x as well. So f of x is equal to f of minus x. Then the function is even. Graphically speaking, such functions will be symmetrical about y-axis. Even function will be symmetrical about y-axis, as you can see. Alright, but if you look at this is odd function. Why? Because whatever is the value of the function, say the value of the function at x is this much, say it is say y1, imagine this is y1. Then the value of the function at minus x will be minus y1. In other words, if the value of the function at x is fx, then the value of the function at minus x will be negative of f of x. Alright, what happened? Okay, cool. So this is the definition. F of minus x is equal to minus fx, then the function is odd. Okay, and such functions are symmetrical about the opposite quadrants. Whatever that is happening in this quadrant will happen in the opposite quadrant. Whatever is happening in, say, this quadrant here will happen in the same will happen in the opposite quadrant. So such functions are symmetrical in the opposite quadrants. Alright? Or the graphs you can see is symmetrical about the opposite quadrants. Alright? Any doubt? Okay. So what is it that you didn't understand here, Deveshwar? If I plot this in Desmos, you'll again see the same thing, right? So the function is whatever, say for example, if the value of x here is 2 and the value of the function is 4, then f of 2 is 4, then f of minus 2 will be how much? Minus 4. That's it. That is all that I'm saying. Okay? Got it? Now, if I apply the same concept in trigonometric graphs, I'll come to that. So again, another example of even and odd graphs. See, this is even graph. Why? You can see the graph is perfectly symmetrical about y-axis. Okay? Whatever that is happening in the positive side of x-axis, exactly the same graph is there in the negative side of x-axis. Right? Got it? But look at this graph. This graph is symmetrical in the opposite quadrants. So the value of the function at x is fx, but the value of the function at minus x is f of minus x. But if you look carefully, f of minus x is equal to minus times fx. Or if this is 2, then this is minus 2, whatever. Got it? Here f of x is equal to f of minus x. Got it? Okay? Deveshwar, everyone, all of you understand, I hope, right? Cool. Now, if you apply the same concept here, can you tell me which one of these functions is even or odd? Say if this function is a, this is b, this is c. Can you quickly tell me which function is even and odd? What do you do? Just do this. Just check this. Step 1. Write f of minus x. All of you write f of minus x. Write f of minus x, all of you. Okay? Just replace x by minus x. What will you see? This. Okay, this will become minus x ki power 5 minus 4 minus x, and this will become 2 minus x ki square minus of minus x minus 1. What will it become? Look carefully. This can be written as 3x square plus 8 or nothing but f of x. Exactly. This can be written as minus can I take minus common outside? Because minus x ki power 5 is minus outside x ki power 5. X ki power 5, similarly minus 4x. Can you write this as minus of fx? This is 2x square plus x minus 1. Nothing. It is neither this is neither f of x nor f of minus x. Okay? So by the definition, you can now easily see that this here f of minus x is equal to fx. So this is even. This is odd because f of minus x is minus fx by definition. This is neither even nor odd. Because f of minus x is neither minus fx nor fx. It is something else. So it is neither even nor odd. Okay? Got it? Nayantra, did you understand? This is neither even nor odd. Okay? Because it is neither fx nor minus fx. Got it? Nayantra, you wrote C is odd, right? I hope you understood. Cool. So, even if you were to plot the graph, for example, if I were to plot the graph of, where is Desmos? किसका ग्राफ प्लॉट करते हैं? इसका प्लॉट करके देखते हैं. लाइक सी x की पावर 5 minus 4x. x की पावर 5 minus say 4x. You can see this graph is odd graph, right? It is whatever is the value of x here. So whatever is the value of y at this x will exactly be the negative at or the opposite at this x, which is minus of this x, right? So graph is symmetrical in the opposite quadrants. But if we were to plot this graph, 3x square plus 8, this though you already know. Y is equal to 3x ki power, what was that? 8 plus 4, whatever. See, this graph is symmetrical about y-axis. So blue graph is even, red graph is odd. Alright? Okay? And third one is neither even nor odd. 2x square minus x minus 1. So 2x square minus x, say minus 1. If you look at it carefully, this is neither even nor odd. If I remove these two, see, this graph is not symmetrical about y-axis, right? Had it been symmetrical about y-axis, this vertex would have been on the y-axis. Alright? So this is neither even nor odd. Okay? Tushar is asking, how do I type the power? I use this symbol. ठीक है, cool. चलो, let's move ahead. So I think these are very, very basic concepts, guys. So I just wanted to refresh it if you didn't know. ठीक है? So this is the same thing which I've explained here, nothing new. Now look at the cos and sine का graph again in the light of even and odd. ठीक है? So y equal to sin x graph, all of you know this, and this is the graph of y is equal to cos x. Can you tell me which one is the even, which one is the odd one? Look carefully at the cos graph. It is perfectly symmetrical about y-axis. So this is your perfectly symmetrical about y-axis. So this is even. Anyways, you already know, the property that cos of minus x is equal to cos x, right? F of minus x is equal to fx. This property you already know. ठीक है? Right? Now, if you look at sine is symmetrical in the opposite quadrants. Sine is symmetrical in the opposite quadrants, right? ठीक है? So this is odd one. This is odd. This is odd. And anyways, you know the property of sine, that sine of a minus x is equal to minus times sine x. Okay, this is something that we have been learning since 10th, 11th, right? Okay, so this is the property of odd. F of minus x is equal to minus times fx. So you can see sine graph is odd, cos graph is even. Now keep this in mind when I'm moving ahead from here. Dipesh, this is exactly what I explained, right? Okay, how sine is odd because sine of minus x. So if you take the value at pi by 4, what is the value of sine? At pi by 4, the value of sine is say 1 by root 2. So f of pi by 4, 1 by root 2. But f of minus pi by 4, f of minus pi by 4 will be what? Minus 1 by root 2, right? So sine of x is this. Sine of minus x is negative of that. Sine of minus x is minus sine x. So this is the property of odd, right? And this is the property of even. Got it? So sine is odd, cos is even. Okay, cool. Chalo, let's move ahead. So these are the fundamentals of the sine graph, cosine graph. Now what are we going to do now? Okay. Now we are going to imagine all the transformations now on top of trigonometric graphs. That will really, really help you imagine and visualize everything about graphs. So this is the sine graph again. I'm just summarizing. Sine is odd function. Sine of minus x is minus sine x. All of you know this. Okay? The maximum and the minimum value of the sine graph is between minus 1 and 1, right? So this is what we call as range of sine function, which we will learn in detail in functions going ahead. But what is the range? The range is what? The area along y-axis in which the graph lies. So graph of sine x lies between minus 1 and 1. So this is what we call as the range of the minimum value and the maximum value of the sine function. Minimum value is minus 1, maximum value is 1. So range of sine function is minus 1 to 1. Right? Okay, domain is all real numbers because we can define the sine graph for all real numbers. Right? We'll discuss about domain in detail when we start functions in depth. But I think in 11th you must have learnt about domain. So you can easily see here, domain is all real numbers because you can take sine of any real number. No problem. Similarly, quickly about the cos. We have learned cos is an even function because cos of minus x is cos x. Cos again lies between minus 1 to 1, right? Maximum value 1, minimum value minus 1. Okay? So the range of cosine function is also minus 1 to 1. Okay? I am restricting my discussion to sine cos now. Okay? With time we will go in depth about the tan cot as well. Okay? Cool. Okay, now let's move to transformations again. Now what are we going to do? Now we are going to learn all the complex transformations. What all transformations did we learn? Multiplying x with something, adding something with the x, adding or subtracting something with y, and multiplying something with f of x, right? So we learned all these transformations in the previous class. This, okay, and y is equal to f of x plus a. We learned all these. This is what we missed last time because I wanted to do this one through trigonometric graphs, and we will combine all these to learn the most complex cases of this. Okay, now let's quickly do it through trigonometry, because through this you will learn about periodic functions as well. So basically in today's class we will have learned quite a lot about periodic functions as well, okay, through graphs. Now let's come to this. Let's do the first transformation, f of x plus minus a. Remember what was that in quadratic graph? In quadratic graph, what was it? The movement along up and down along y-axis. Remember that? Up and down along y-axis. If this is y equal to fx, we learned if this is a, this is minus a, then y plus a karoge to the graph. Sorry. If you'll do y minus a, then the graph moves up. If you'll do y plus a, then the graph moves down, right? This is what we did last time. Now can you visualize what will happen here? What are we doing here? We are doing y is equal to f of x plus 2, or what we are doing here? We are doing y is equal to f of x minus 1, and I also told you how to visualize it. Another way to visualize this is y minus 2 is equal to fx, or another way to visualize this is, as we did last time, y plus 1 is equal to fx. Remember? So the graph should go up, the graph should go down. Can you make a rough version of it in your notebooks, all of you? Okay? Make a rough version of it in your notebooks, all of you. Try to do it. Here the graph will go up by 2. Take out the entire graph and move it up by 2. Here, take out the entire graph and move it entirely down by 1. Alright. So, see, let me know if you're facing any doubt here. Red one is your y equal to sine x. Red one is y equal to sine x. Okay? The entire graph has been shifted up. Okay? So this value 1 moved to, so what was 1 now moved to 3. What was 0 moved to 2. And what was minus 1? Okay? Moved to 1. Okay? So this is our graph. Which graph is this? This is y is equal to sine of x plus 2. Okay? Similarly, what is the green one? I think by now we did a lot of this in quadratic graphs. Now we are doing it. Okay? Y equal to sine x minus 1. The entire graph has been shifted down. So 1 goes to 0, 0 goes to minus 1, and minus 1 goes to minus 2. Correct? So now can you tell me the range of, can you tell me its range? What is its range now? This graph lies between what to what? And what is the range of sine of x plus 2? Can you tell me its range? What is range? Simply speaking, the values along y between which the graph lies. Take it, batao, all of you, write it yourself. Okay, this blue shaded area is the range of sine x plus 2. Kitna ho gaya? The minimum value is minus 1 and the maximum value is 3. Look at the green graph. The green graph, the maximum value is 0 and the minimum value is -2. So this graph lies between -2 to 0. Any doubt in this, guys? Anybody, any doubt in this? Okay. So you should be able to visualize ranges graphically. This is what we are learning here. Right, Tushar, what's your doubt? Correct? So blue, it's 1, 2, 3. Oh, sorry. हाँ 1 है ना, मैंने क्या लिख दिया? Oh, minus कहाँ से आ गया? Oh, my bad. So sorry. -1 कहाँ से आ गया यहाँ पे? Of course 1. ठीक है? This is 1. 1 से 3. This is -2 to 0. And sin x का range कितना होता है? The sin x का range, all of you know. The sin x का range is -1 to 1. So basically when you added 2, both minimum and the maximum value got increased by 2. And when you subtracted 1, okay, when the graph went down, the both minimum and the maximum values decreased by 1. Correct? Okay, chalo. So this is again vertical transformation as we learned previously. This is the case of vertical transformations. Okay, this is the vertical shift. Remember, we did it previously. You know this. Nothing special here. The graph goes up or the graph goes down. Achha guys, one more thing. Chalo, I'll discuss about that a bit later. Anyways, let's move ahead. So graph goes up, graph goes down. This we did in the quadratic graph, so nothing special here. Yeah. Now, let's look at the change in x. What was the case that we just did? This is the change in y. Remember? This is the change in y. Now we are doing the change in x. Alright. So the change in x में क्या होगा? The movement, of course, you understand, will be along x-axis. Can you plot the graphs? You know the graph of sin x. Please try to plot these graphs. This is y is equal to f of x plus pi by 2. This is the graph of y is equal to f of x plus pi, and say this is the graph of y is equal to f of x plus 2 pi. Hello? What will happen? The graph will move. In fact, rather than this one, instead of this one, to compare, you can plot, say, minus. Anyways, I'll show you in Desmos. Plot it, all of you, in your notebooks. Y is equal to sin x, all of you know. Now, let's plot y is equal to sin x plus. When I will do plus pi by 2, what will happen? The graph will move. Look at this. I'm going to write 2. जैसे लिखूंगा 2, it will move towards left. Left. Can you visualize? The graph has moved left. Look at this. Look at how I'm showing you. This orange, this point, move it towards left. This point actually is pi. X here is minus pi by 2, right? So what happened? This 0 wala point moved left towards this. This 1 wala point moved left towards here. And this point moved left towards here. So the entire graph moved towards left. And can you see this graph is exactly like cos x? And all of you know, sin x plus pi by 2 is nothing but y is equal to cos x, right? You know this, right? So this graph is nothing but cos x also. Because you know that sin x plus pi by 2 is nothing but cos x, right? Similarly, if you were to plot sin, say x, if I were to do what? Say plus pi, then the graph will move pi towards left. Look at this orange one. Shift this, take it out and move it entirely behind by pi. So whatever was happening at 0 will now happen at minus pi. Whatever was happening at 0 is now happening at minus pi. Alright. So that is how the graph shifts along x-axis. All right? Okay? Even graph, it will be even graph only when the graph is symmetrical about x-axis. So which one of this is the even graph? This one. This graph is the even graph. X plus pi by 2 has become even. Okay? Because it has become symmetrical about y-axis. This is actually equal to cos x. Cool? So, just to summarize, so these are our graphs. ठीक है, देखो कौन कौन से ग्राफ मैंने प्लॉट किए हैं. The red one is sin x. ठीक है, the blue one is sin x plus pi by 2. Think like this. This portion shifted back by how much? Shifted behind by pi by 2. ठीक है, this also shifted behind by pi by 2. है ना? So this point is minus pi by 2. This point is minus pi. This point is pi by 2. This point is pi. Alright, and this point is 3 pi by 2. Okay, so see, all points shifted behind by pi by 2. In which graph? The graph is sine x plus pi by 2. Now, if you look at the green graph, this is x plus y is equal to sine x plus pi. Because all points now shifted, if you look at this point, this actually got shifted much behind here. It got shifted here to minus pi. Okay? If you look at this point, this actually got shifted so behind. This gap is pi. Pi by 2 ko pi se reduce karo, you will get minus pi by 2, right? Got it? So that is how you can visualize the graph shifting behind or towards the left or the right of the graph. Got it? So this is our horizontal transformation. This is our horizontal transformation which we had learnt through the quadratic graphs. Now we are learning the same thing using the trigonometric graphs. Concept is the same. Okay? Got it? I'm moving ahead now. Yes, Deveshwar, you are right. This has become minus sine x. Why? Exactly, because you already know the property. This is nothing but minus sine x. And you also know the property. This is nothing but cos x. So if you look at the red graph, if you look at the green graph actually is also the graph of minus sine x. This is also the graph of minus sine x. Because these two are the same. Similarly, the blue graph is also the graph of cos x because these two are the same. Good observation. Okay, cool. So now you are actually playing with graphs. You are deducing lots of inferences through the graphs. This is exactly what I want you to do. Okay? You know, everything is right there in front of your eyes if you can visualize. Okay? All the relations, all these results that you have learned in trigonometry, all of this you can easily visualize through graphs. Okay? Now let's move to the next case. So this is the horizontal shift wala case. So this is the case of horizontal shift. Again, nothing special here, we have already learned. Now, let me take the case of A times fx. Now I will also talk in terms of physics. Now I'll start using some notations of physics as well. Okay, like amplitude, like frequency. Okay? Now let's discuss that as well. But before that, let's try to understand what are we doing here. We are now multiplying fx by a. So between moving from here to here, what you're doing, you're saying that now my function is 2 times fx, a times fx, right? Now between moving from here to here, my function is half times fx. And we just saw the graph of minus sine x, which is nothing but y is equal to minus of fx. Okay? Remember what used to happen in quadratic graphs? Stretch up or push down. Okay? What was that? You know, pull up or push down wala case. This was the case of a times fx. In quadratic, the graph used to get either thinner or flatter based on if the value of a was more than 1 or a fractional value. This is what we did in quadratic. Now, can you plot these graphs on your own? Can you plot these graphs on your own? Try. All of you try. Try in your notebooks quickly. Also think about the ranges. Also think about the range. When you plot the graph, please also think about the range. All right. Dekha, this is 2 times, this is 2 sine x. This is the graph of 2 sine x. What happened? Where the sine was 0, it will remain to be 0. Agree? Agree? At pi, both sine and 2 sine are 0, but rest all values got multiplied by 2. So the graph got stretched up. Look at me in the video. The graph got stretched up. Or in the negative side, it got stretched down. Okay? But had the value been, so what is the range, by the way? The range is from -2 to 2. The range of this is -2 to 2. But if I reduce it, make it fraction, say 0.5 or half, see what will happen? At 0.5, what will happen? For example, the graph has become flatter. The graph has sort of flattened. Okay? Yeah, compressed. It got compressed. As if in the, किसी ने हवा निकाल दिया, as if somebody, took the air. Had this been tires, had this orange graph been a balloon of some sort, okay? If you, take the air out, it will be the case of this when a is a fractional value. And if you fill the air, it is the case of when a is greater than 1. So this is the case. Now, in the language of physics, what is happening? See, I have by the way, my voice is very bad, but if I speak loudly, my voice is my voice, but its volume has increased. So, you know what? This is what we call as amplitude. This is the amplitude. Okay? So, when you multiply the function by a, when a is greater than 1, you are increasing the amplitude. If it is a sound wave, then you are turning the volume up. A is more than 1, you are turning the volume up. If a is less than 1, you are turning the volume down. The volume down, volume up. Volume down, volume up. Amplitude is changing, not the frequency. Amplitude is changing, not the frequency. Got it? So this is the physical, this is the visualization in the world of physics. Okay? So let's look at this. This is the generalization. This is the graphs. So red one is your y is equal to sine x. The blue one is your y is equal to 2 sine x. What happened? Somebody pulled it up, both in negative and the positive directions, filled the air. But in the case of this one, green one, somebody has pushed it down on both the sides, negative and the positive side, so it becomes y. And this is -half. So iska range kitna ho jayega? Its range will be -half. Yeah, harsh, no. The sound is loud, the sound is feeble. Yes, feeble, good. Sanmati, Tushar, softer, feeble, yes, you are right. Okay. Now, what if we multiply by the negative? So which we saw in the Desmos also, na? What if you multiply by negative? So let's do the negative. So 0 and negative. So minus x. This is the minus x, right? This is the minus x. The graph, what happened? Positive became negative, negative became positive. That's it. Okay? -2, -3, so on and so forth. Okay? Negative behavior, all of you know. The negative behavior is what? This inversion happens. This is the inversion. The positive becomes negative, the negative becomes positive. So if the red one was the graph of sine x, then the blue one, its inverted version, becomes a graph of y is equal to minus sine x. Okay? And similarly, this is the graph of y is equal to minus 2 sine x. Alright? Cool. Can you hear me? No, wavelength change, Deveshwar, I am coming to that. But somebody was talking about f of fx. There are many such cases. That is composite function. We will learn that in functions. Okay? We will do lot of stuff. In fact, with time, we will learn all these random stuff. What about this? What about this? What about this? What about f of fractional part of greatest integer of whatever. With time, you will be able to do all this. Don't worry. Okay? With time, you will learn to do all that. But now your fundamentals are set. Now you have learned how to visualize transformations. Aage sab ho jayega. Don't worry. Everything we will do. So this is vertical stretch. This is the vertical stretch. Either these dudes pull up or push down, right? Vertically. So this is the case which we learned